There are moments in advanced mobility design when a vehicle stops behaving like transportation and instead begins behaving like architecture in motion. And standing before this machine, that threshold feels distinctly crossed. What we are observing here is not a production motorhome, nor a market-ready prototype, but rather a speculative design study, an AI-generated conceptual exploration of what ultra-luxury terrestrial mobility could become if unconstrained by current regulatory, manufacturing, and infrastructure limitations. And yet, despite its fictional origin, the engineering logic embedded within its form language invites serious analysis. The vehicle presents itself as an approximately 45 to 50 foot long tri-axle expedition motor platform, with a commanding height likely approaching 13.5 to 14 feet and a width that visually presses toward the legal limits of highway feasibility. The stance is assertive but not clumsy. Its mass is distributed longitudinally in a way that suggests deliberate weight balancing across three axles, with the forward axle positioned relatively far aft compared to conventional RV proportions. This short front overhang, combined with a long rear deck structure, signals a structural strategy that prioritizes central load concentration, likely placing energy storage modules, water systems, and mechanical equipment low and mid-chassis to control the center of gravity. The wheelbase logic implies a reinforced ladder frame or monocoque hybrid chassis, possibly integrating high-tensile steel substructures with carbon composite superstructure panels to reduce upper mass while preserving torsional rigidity. From a structural engineering standpoint, a vehicle of this size incorporating so much glass and multi-level deck architecture would require significant shear reinforcement within the sidewalls, likely hidden within pillar structures and crossmembers that double as aesthetic elements. Despite its scale, the vehicle avoids the slab-sided monotony typical of large recreational vehicles. Instead, the surface modeling is tensioned and faceted, drawing clear influence from aerospace fuselage segmentation and armored expedition vehicles. Notice how the forward fascia integrates sharply defined geometric planes that converge toward the central grille structure. This isn't merely stylistic aggression. The angular transitions serve aerodynamic redirection purposes, managing airflow separation at highway speeds and reducing turbulent drag zones that traditionally plague large, flat-front motorhomes. The windshield rake is surprisingly aggressive for a vehicle in this class. Rather than the upright bus-style front common in RV architecture, the glazing leans rearward at a performance-oriented angle, suggesting a design intention to reduce frontal pressure zones and wind resistance. The roofline subtly tapers toward the rear upper deck, minimizing vortex formation at the trailing edge. While a vehicle of this frontal area will inevitably produce significant drag, this design demonstrates an awareness of airflow management that aligns more closely with high-speed coach engineering than conventional RV box geometry. The triaxle setup is not purely aesthetic. For a structure that includes a rooftop terrace, integrated plunge pool, expansive glazing, and what appears to be a deployable side platform, load distribution becomes critical. A third axle reduces individual axle load stress, improves braking stability, and enhances lateral composure during crosswinds. From an engineering perspective, this also allows greater gross vehicle weight capacity without overburdening suspension components. The tires appear to be all-terrain performance hybrids, wide-profile, reinforced sidewalls, suggesting an intention for light off-grid capability rather than purely paved touring. The wheel design itself is aerodynamically conscious. The multi-spoke geometry appears partially shrouded, reducing rotational turbulence while maintaining brake cooling pathways. The illuminated rim accents, while speculative, suggest integrated power channels within the hub assembly, which would require robust sealed electrical routing if translated into physical form. Suspension-wise, one could reasonably assume adaptive air suspension with real-time leveling capability, essential for rooftop stability and deployment of the external staircase and side deck system. The exterior finish presents as a deep satin metallic navy, possibly incorporating ceramic-infused clear coat technology to manage thermal absorption. Dark finishes on large vehicles pose significant heat challenges. For this to function in real-world desert climates, the paint system would require infrared reflective pigments and multi-layer insulation beneath the outer panels. The bronze or champagne-toned accent trim introduces visual warmth against the cool blue bodywork, but it also implies multi-material integration, likely anodized aluminum or titanium-coated panels. The interplay of matte and gloss surfaces suggests careful consideration of light diffusion across sharp creases. Under artificial lighting, the faceted planes catch highlights in a way that enhances perceived dimensionality, an architectural lighting principle rather than automotive convention. The lighting architecture is particularly sophisticated. The vertical LED elements integrated into the front bumper form a strong visual signature, functioning as daytime running light pillars. Above them, horizontally stacked DRLs create a layered hierarchy, establishing both width and technological presence. This tiered beam architecture implies matrix LED or even laser-assisted headlamp systems. From a functional standpoint, such lighting would improve night visibility dramatically on remote highways, while also serving as an unmistakable brand identifier. The rear lighting, though partially obscured, appears symmetrical and integrated into aerodynamic channels, possibly doubling as airflow exits. Lighting here is not ornamental. It defines the vehicle's identity in low-light environments, reinforcing its architectural authority. Perhaps the most ambitious element is the extensive use of floor-to-ceiling glazing along the side and upper deck. The glass-to-body ratio is extraordinary for a vehicle of this scale. In real-world application, this would necessitate laminated structural glass with polycarbonate interlays for impact resistance and acoustic isolation. Electrochromic tinting would almost certainly be required to manage solar load and privacy. The structural implications are significant. Large glass apertures weaken sidewall rigidity unless compensated by reinforced pillar structures and bonded composite frames. Given the visible angular framing around the windows, I suspect this concept imagines a skeletal exoskeleton that doubles as aesthetic armor while quietly performing load-bearing duties. The rooftop is not passive. We see integrated solar panels flush-mounted into the upper surface, alongside what appears to be a radar dome or satellite communication module. If this were engineered into reality, the solar array might contribute 1.5 to 2.5 kilowatts under optimal sunlight, supplemental, not primary, but meaningful for auxiliary systems. The upper deck terrace introduces significant structural complexity. Supporting live loads, furniture, occupants, possibly water features, require reinforced subflooring and torsion-resistant beams integrated into the roofline. The deployable staircase and side deck system suggest hydraulic actuation mechanisms housed within the lower skirt panels. From an engineering perspective, this transforms the vehicle from a motorhome into a mobile hospitality pavilion. Traditional RV architecture prioritizes interior volume at the expense of exterior sophistication. This concept reverses that hierarchy. It treats the vehicle as a luxury expedition yacht translated onto wheels, borrowing from marine decking logic, aerospace surface articulation, and high-end residential architecture. In terms of luxury positioning, this occupies a tier beyond conventional Class A motorhomes. It targets an ultra-affluent, design-literate user archetype, someone who values experiential architecture as much as mobility. My initial assessment is that this concept leans revolutionary in form, but evolutionary in functional logic. The engineering challenges are immense. Weight management, structural reinforcement, energy density, and safety compliance would all require breakthroughs. But as a speculative design exploration, it successfully reframes what a motorhome can visually represent. It is less a vehicle, more a rolling architectural manifesto.
Although the interior is partially visible, much must be logically inferred from the exterior proportions and structural cues. Given the vehicle's length and triaxle configuration, I estimate a usable interior floor length of approximately 38 to 40 feet. The ceiling height on the main deck likely approaches 7.5 feet, while the upper deck lounge may offer slightly reduced clearance due to roof reinforcement beams. Load-bearing pillars would align vertically from chassis rails through window frames to roof supports, creating invisible structural corridors that dictate furniture placement. The forward lounge area, visible through the panoramic windshield, appears to function as a primary living salon. Its elevated positioning over the front axle suggests careful balancing of seating mass against drivetrain components below. The upper deck bedroom, visible through the glass, suggests a loft-style master suite. Placing sleeping quarters above increases privacy and separates rest zones from mechanical noise near the chassis. However, thermal insulation becomes critical at that elevation. Multi-layer insulation panels and active climate zoning would be required to maintain comfort in extreme environments. Acoustic isolation from wind noise would necessitate triple-sealed glazing and laminated panels. A vehicle of this ambition would logically integrate induction cooking surfaces to reduce open flame risk. Water storage capacity might approach 150 to 200 gallons when combining freshwater and graywater tanks, distributed longitudinally to prevent imbalance during acceleration and braking. Energy consumption would be carefully monitored through an onboard AI energy management system, optimizing solar input, regenerative braking capture, and battery discharge rates. Given the luxury tier implied, a modular wet-dry bath separation would be expected. Graywater filtration and partial recycling systems could extend off-grid autonomy to 7 to 10 days under conservative use. Ventilation would require roof-integrated extraction systems with humidity sensors to prevent condensation within insulated wall cavities. Driver visibility from the expansive windshield would be extraordinary. However, glare management would require polarized and possibly electrochromic layers. A semi-autonomous Level 3 or Level 4 driving assistance suite is plausible in conceptual terms, integrating LiDAR within the roof module and radar sensors embedded in the front fascia. Control hierarchy would likely centralize into a panoramic OLED display cluster, minimizing physical switches while maintaining tactile redundancies for safety-critical inputs. Given its conceptual futurism, a hydrogen-electric hybrid architecture would align with the design narrative. Hydrogen fuel cells could provide extended range, while high-density solid-state batteries manage peak load demands. Regenerative braking across 3 axles would significantly enhance energy recapture efficiency. Solar panels would realistically contribute modestly, perhaps covering auxiliary loads rather than propulsion. For future long-range mobility platforms, battery energy density improvements of at least 40% beyond current lithium-ion benchmarks would be necessary to make such a vehicle viable without extreme weight penalties. An AI-driven environmental system could continuously monitor cabin occupancy, external temperature, and energy reserves to dynamically adjust climate zones. Satellite connectivity integrated into the roof dome would allow real-time terrain mapping and remote diagnostics. Structural health monitoring sensors embedded within the chassis could detect torsional stress during uneven terrain travel. For long-distance touring, highway composure would depend heavily on crosswind stabilization algorithms and adaptive suspension compensation. In urban settings, maneuverability would remain a challenge, despite multi-axle steering possibilities. Off-grid capability would be impressive, but not unlimited. Weight and energy constraints remain physics-bound realities. To translate this into physical existence would require advances in composite manufacturing scalability, battery density, lightweight structural glass, and integrated hydrogen infrastructure. Current limitations in cost, safety regulation, and infrastructure compatibility prevent immediate real-world feasibility. Yet conceptually, this is not absurd. It is aspirational, but grounded in emerging technological trajectories. What fascinates me most is not its extravagance. It is the way it treats mobility as architecture, blurring boundaries between dwelling and vehicle without surrendering to cartoonish excess. As a fictional AI-generated design study, it succeeds because it provokes serious engineering questions rather than offering fantasy alone. And in the realm of future mobility exploration, that intellectual provocation is far more valuable than spectacle.